Next we're going to look at multiplying polynomials together. So let's get to it. We've got x plus 6 times 5x minus 1. Now, when you learn this, you might have learned something called the FOIL method, which I'm not really going to use because it's kind of limited. It only applies to when you have a binomial, so 2 terms times another binomial times 2 terms. But a lot of times when we're working with polynomials, there's more than 2 terms. So I'm just going to kind of do a method that works no matter the number of terms you have. So generally speaking, when you're multiplying 2 polynomials together, you have to take all of the terms from one polynomial and distribute them across the terms from the other polynomial. So here's what I mean. So I'm going to take this x plus 6. I'm going to take each term separately. So I'll start with the x. And I'm going to rewrite it so that it's distributing across the 5x minus 1. So this x has to multiply across both parts. So I'm going to rewrite this to be x times 5x minus 1. Okay? But then you also have to distribute the 6 across 5x minus 1. The 6 also has to multiply by 5x minus 1. So I'm going to write plus 6 distributing across 5x minus 1. And now all that's left to do is to distribute and then combine like terms and simplify. So the first one, if I distribute, I got x times 5x, which is going to be 5x squared. Then I've got x times minus 1, which will be minus 1x, or just minus x. Then I've got a positive 6 times 5x, which will become positive or plus 30x. Then I've got 6 times negative 1, which is just minus 6. Okay, 6 times negative 1 is minus or negative 6. Okay, and then I'm almost done. All I got to do is see if there's any like terms to combine, and there are a couple because there's a x to the first, negative x to the first, and a positive 30x to the first. So negative 1 and positive 30 makes positive 29. So I can rewrite this to be 5x squared plus 29x minus 6. And that is as far as I can go. Okay, now I'm going to apply the same process over here to this next problem. It's going to be a little longer because it's a trinomial times a trinomial, 3 terms times 3 terms. So I'm just going to rewrite this to be 3 different distributive properties. So first, the x cubed. So it's going to be x cubed times x squared plus 5x minus 6. Then I'm going to distribute the negative 2x squared. So minus 2x squared times x squared plus 5x minus 6. Then I still have to distribute the plus 5. So plus 5 times x squared plus 5x minus 6. Okay, and now once again I just have to distribute everything and combine like terms. So I'll start over here. So x cubed times x squared is x to the 5th. X cubed times 5x is 5x to the 4th. And x cubed times minus 6 is minus 6x cubed. Okay, and then over here I'm distributing. Now keep in mind, as I distribute this, there's a negative in front, so it's going to change the sign of all these. So negative 2x squared times x squared is going to become minus 2x to the 4th. Okay, negative 2x squared times 5x is negative 10x cubed, or minus 10x cubed. Negative 2x squared times minus 6 is going to become positive 12x squared. Negative times a negative is plus or positive. Alright, so now I'm going to move on to the last set, and so I got 5 times x squared, so that would just become 5x squared. I've got 5 times 5x, so that's 25x. Then I've got 5 times minus 6, so that is minus 30. Okay, so now I'm just going to see what like terms I have to combine together. So I'll start over here. I've got x to the fifth. You'll notice there are no other x to the fifth terms, so that will just be x to the fifth. Now, if you have a big long string like this, it might help to kind of keep track to cross them out or cancel them out as you use them, so you don't get confused. Okay, so then I've got x to the fourth, 5x to the fourth, and I got a negative 2x to the fourth. 5 and negative 2 is a positive 3, so I'm going to have plus 3x to the fourth. So I've used all the x to the fourth terms. Okay, now I'm moving on to x to the third. So I've got a negative 6x to the third, a negative 10x to the third, so that'll be negative 16x to the third. And the x to the third terms are gone. Do I have any x squared terms? I do. I got a 12x squared and a 5x squared. 12 and 5 is 17, so I'll have plus 17x squared. Okay, then I got two terms left, and you can see this is the only x term, so it's just plus 25, plus 25x, and this is the only constant term without a variable, so just minus 30 on the end, and that is as far as I can go. And if you kind of go in descending order to start with, your answer will already be in standard form when you're done. So, all right. Moving on down here. So now I've got 3x minus 4 squared. So this is going to be very much like this problem, except it's going to be the same term multiplied by itself twice. So a way to rewrite this, or to think of this one, is just 3x minus 4 times 3x minus 4. Okay? Now, if you can kind of keep track in your head, you don't really have to write out every single step if you don't want to. It can help you keep track. But like for this one, 3x times 3x is 9x squared. 3x times minus 4 is minus 12x. Minus 4 times 3x is minus 12x. And minus 4 times minus 4 is plus 16. Okay, so then all I got left to do is to combine. I can combine the minus 12x and minus 12x together to get minus 24x. So I've got 9x squared minus 24x plus 16. And I'm done. Okay, so over here, same thing, except it's to the third power. So when I kind of write this out, I've got x plus 5, x plus 5, x plus 5. Okay. So when I have several polynomials multiplying by each other, like more than two, basically you can pick out two of the polynomials, multiply those together, and then multiply by the third one when you're done simplifying the first two. So that's what I'm going to do here. So I got x plus 5 times x plus 5. So x times x is x squared. X times plus 5 is plus 5x. Moving on, 5 times x is plus 5x. And 5 times 5 is plus 25. Oops. Okay, and this whole thing is still being taken times x plus 5. And I can combine these two together to make it plus 10x. So what I actually have is x squared plus 10x plus 25 times x plus 5. Okay, so now I'm going to distribute all three of these across x plus 5 and then see what happens. So I got x cubed times x, so that's, x squared times x, which will become x cubed. I've got x squared times 5, which will become plus 5x squared. I've got 10x times x, which will become plus 10x squared. I got 10x times 5, which will become plus 50x. I've got 25 times x, which will become 25x. And I've got 25 times 5, which is 125. All right. So now I'm just got to combine like terms together. X cubed, there are no like terms with that. X squared though, there's a 5 and a 10, so that'll be 15x squared. X, I got 1525, so that's 75x. And then the 125, there are no like terms with that. There are no other constant terms, so it's just plus 125. And so that is as far as I can go. Now, there are some other shortcuts you might have learned for multiplying expressions such as these. Last year in Algebra 2, you probably learned some binomial expansion, which used Pascal's triangle, if you remember that. So feel free to use that if you want to also. It won't come up all that often this year, but every once in a while you will have to expand out a binomial like this.